Okay, so today we are going to study about the nuclear reactor. Nuclear reactor actually works on the nuclear reactions. We discuss two type of nuclear reactions, nuclear fission and nuclear fusion reaction. And nuclear reactor works on the nuclear reaction also. Like there are electricity power plant in many countries. Those actually works on the nuclear reaction because in nuclear reactor uh, definitely we are going to perform nuclear reaction to generate electricity. That's why they are called nuclear reactor. And you can see it is mentioned nuclear reactors works on fission reaction to generate electricity. Fission reaction means to split up a heavy nucleus into two lighter nuclei. So this is the working of nuclear fission reactor. So the setup is very simple.
अस्सलाम वालेकुम सर।
Walaikum assalam. In this setup, you can see there are some important components. Important components are the first one is the control rod. This is the important component in this nuclear reactor because in exam they ask about some specific components. So the first important component is control rod. Secondly, you can see it is written uranium fuel element. So it means we are using uranium to start the reaction, or we can say we are using uranium as the fuel of the reaction. Okay, this is the main source to start fission reaction. So we are using uranium as the fuel element in this nuclear reactor. And the other elements are also marked. We have molten sodium or liquid water under high pressure, and also we have reactor core. And in the other compartment, we have steam and then normal electricity generator, and rest of the hot water carries back towards the reactor. So let's see how this process works in the nuclear reaction or nuclear reactor with the help of fission reaction. So first of all, step number one. Step number one is uranium rods are struck by neutrons to initiate fission reaction. So initially, reaction is simple, just like the fission reaction, because in fission reaction we discuss we need to strike neutron into the nucleus of an atom, right? So that's why uranium rods are struck by the neutrons to initiate fission reaction. This is the first step. You can see in the diagram we have uranium rods. It is written uranium fuel element. So red color rods are uranium rods. So if you like apply the concept of the nuclear fission reaction on the uranium rod, so you will get the idea. This is same like the nuclear fission reaction because we need when you need to start the fission reaction, we require neutrons to strike into the nucleus. So in the same way, in the first step, uranium rods are struck by neutron to initiate fission reaction. Second step, Second step is this heat is carried to water using molten salt, where water turns to steam. And we also know about a very process of generating electricity, just like from the dam and from the old example of the steam engine. Nowadays, we are using electric train and normal trains with electricity. But in the old time, there is a concept of steam engine, right? There is a coal, and people used to burn that coal and to generate steam, and that steam helps to generate electricity with the help of the water. In the same way, in this nuclear reactor, we are using fission reaction, because in fission reaction we also gets very high amount of thermal energy, right? So in the same way, we are using that heat energy. It is written, this heat is carried to water using molten salt, where water turns into steam. In the second compartment, you can see there is a pipe from the first compartment coming into the water, because when we start fission reaction, so due to fission reaction, thermal energy starts to generate over there in very high amount, because in nuclear fission reaction, nuclear fusion reaction, very high amount of thermal energy generates, and this heat energy transfers from this reactor into the second compartment. So this heat energy transfers from the first compartment into the second compartment, right? And definitely, when high amount of thermal energy passes through the water, so it starts to convert into the steam, and definitely steam starts to flow in upward direction. So steam definitely flows in this direction towards the generator, right? And definitely that steam move towards the generator, it rotates the turbine, and when it rotates the turbine, so it generates electricity. So you can see the third step is steam is used to drive the turbine, which drives the generator. Turbine means there is a large size fan, right? And when that fan starts to rotate, so it generates electricity. Normally in our home, what we use, basically we use electricity to rotate the fan. And if you like reverse this process, for example, if you rotate that fan by yourself, so you will get electricity. Okay, reverse process. Normally we use electricity to rotate the fan, but if you rotate the fan mechanically, so you will get electricity on the other end. So that's why we are using the same concept over here. We start to rotate turbine, that large fan, to generate electricity, okay, with the help of the steam. So this is the process of nuclear reactor, okay. Any confusion in basic concept of reaction, that how this reaction takes place?
No, sir.
Because reaction is very simple and very like to the point, not very like complicated one. There is no equation, there is no formula required for the working of it. So that is very simple. But there are components like control rod and uranium fuel element. So if we talk about control rod, why we are using control rod, that is not, control rod is also not mentioned in the process. So why we are using control rod? It is given in the diagram also. So what is the working of it? So basically, The purpose of control rod is given over here. And before that, you can see one more step is mentioned. The steam is then condensed back to liquid using cold water in the condenser. As you can see in the diagram, the last compartment, this one. So that is steam. When steam cools down, it again converts into the liquid, and then this liquid is going to be transferred towards the steam compartment again. Okay, simple process. So basically, we are using water and we are getting thermal energy from fission reaction. And when water gets thermal energy, it converts into the steam, and that steam transfers into the generator because it rotates the turbine. And when it rotates the turbine, it generates electricity. And the rest of the steam moves back towards the third compartment, where that steam again converts into the water state because there is a transfer of cold water takes place. So because of low temperature, that steam again converts into the liquid, and that liquid again moves back towards the second compartment of the steam. Okay, and it again converts into steam, and this process uh, carries on continuously. And the concept of the control rod is, you can see it is mentioned, these rods are used to control the speed of the reaction by adjusting the quantity of neutrons in the reactor. Okay. So basically you can see these gray rods are actually the control rods. Okay. So what happens with the control rods and why we are using control rods? For example, if we have uranium rods, because in diagram it is clearly mentioned we are using uranium for nuclear reaction. So for example, if we have uranium rods in the reactor like this, so these are uranium rods, let's suppose, and we are continuously striking neutrons on these uranium rods, right? So to start fission reaction, we need to strike neutrons on the uranium rods. And when neutrons strikes the uranium rod, so reaction takes place, right? And to control the reaction, let's suppose if you are getting so many electrons colliding with the uranium rod, and you observe that the temperature of your reaction is now so much high, right? Because it is not necessary to increase temperature so much high because we need to control that process also. So when you think that your temperature of reaction is very high and we are not able to control that thermal energy, or we are not able to control that reaction, so what we do, we just insert the control rod. Okay, so let's suppose if your reaction is producing so much amount of thermal energy, so then we use the control rod. So these yellow rods are the control rods. So these control rods absorbs the neutrons. Okay. So most of the neutrons are absorbed by the control rods. Okay. So when most of the neutrons are absorbed by control rods, so definitely your reaction automatically slows down. Okay, because initially there is no control rod, and all the neutrons are striking with uranium rods, and they produce very high rate of reaction, fission reaction. But when we use control rod, so with the help of the control rod, neutrons are absorbed by the control rods and it will slow down the reaction. So this is the working of control rods. Okay, and that's why they are also called control rods. Yes, any question?
Sir, I was saying that when the neutrons hit the uranium rods and stuff,
Mhm.
like like there's heat that is produced, right?
Mhm. Yes, we are getting, because in fission reaction, we studied that it also generates very high amount of thermal energy. So we are using that thermal
Uh,
energy.
so sir, in exam, do we have to like explain how they're producing heat or something?
No, they will not ask very much detail. We will practice the question also. Uh, in old syllabus, they ask very detailed questions about nuclear reactor, but after 2023, after the syllabus change, now they ask very limited questions from the nuclear reactor, because it is like a very copy paste concept, right? You observe that there is nothing to practice in the calculation form. So in your exam, they mostly focus on the conceptual ideas and the calculation part. This is like a copy paste process, simply just like in the any other process, because this process is already given. You just need to learn this process, and when they ask questions, so you need to simply answer that part only. So this topic is very simple as compared to the other topics, because in other topics we need to learn the concept, we need to practice the numericals also. So that's why in new paper they are like asking question very in very limited form.
Okay, sir, I got it.
And we have one more element, that is called moderator. Okay, and moderator is to slow down the neutrons in nuclear reactor. So let's suppose if we are not using control rod, because control rods are directly getting or absorbing that neutrons coming towards the uranium rods, absorbs neutrons. So let's suppose before control rods, let's suppose if you are not inserting the control rod into the reactor, so we have another option. Another option is the moderator. So moderator is like a liquid or chemical we are using in the reactor. Just like in the diagram, you can see there is a molten sodium or liquid water. Okay, so this is called moderator. So on the name of moderator, we are using a liquid or a solution of any type of liquid to moderate your reaction. Moderate means to keep your reaction in a stable state. Like you will not get very high amount of energy or not very low amount of energy. It will be around your um average value of thermal energy. So basically, what actually why we are using moderator, to slow down the neutrons in nuclear reactor, because definitely neutrons are striking continuously on uranium rod. So to slow down them, we are using moderator. So when neutrons are slowed down, so they strike the uranium rods less frequently, and it will slow down the process. And moderator is a material that is not able to absorb neutron. Okay, it will only slow down, just like the resistance. So moderator is like a resistance that actually slows down the flow of neutrons in the reactor. So when the neutrons are slowed down, so definitely your reaction rate will be also slow down, and that will give you stability in your nuclear fission reaction in nuclear reactor. Okay. So these are two type of we can say components that give you stability, or you can control your reaction with the help of these two different processes in the nuclear reactor. Okay. So now if we practice some questions related to the nuclear reactor, so let's see how we can solve the questions. So the questions related to nuclear reactors are, okay, you will get like mixed parts of the question of nuclear reactor in the question of nuclear physics. Like this is question number 8, and we got uranium 235 is the isotope of uranium that is used as a fuel in nuclear power station. So you can see question starts with the reference of nuclear power station or nuclear reactor. And the first part of the question is the isotope of uranium that is most abundant in nature is uranium 238. So this is most abundant isotope naturally. So state how a neutral atom of uranium 235 differs from a neutral atom of uranium 238. So what is the difference between uranium 235 and 238? We already discussed this type of questions before the topic of half-life. So if you compare
Um, but
these, hmm,
sir, I think it has three more protons.
3 more protons as compared to 235,
Yes.
right? So we know that with the help of atomic number and atomic mass, you can easily get your answer from this question. We have more number of protons as compared to the other isotopes. So this is the answer of your question. Okay. So we can say there are 3 more protons in 238 as compared to uranium 235.
Sir, instead of protons, won't we write neutrons? Because the difference is isotope
Yes,
is
sorry, it is
neutrons.
neutrons. Yes, yes. Because we have a same number of protons in isotopes. Yes, sorry. We need to write for
Okay, sir.
neutrons because in isotopes we know that we have same number of protons. It is 92, 92. So we have same protons. So definitely neutrons are different. So you can write like three more neutrons in 238, or you can write there are three less neutrons in 235 as compared to 238. Correct. Okay, part B. In part B, in the reactor of a nuclear power station, a nucleus of uranium 235. So they are asking about reactor. And uranium 235 absorbs a slow moving neutron and undergoes fission, right? The same process we discussed, that there are uranium rods and uranium rods absorb neutron to start fission reaction. So state what happens to the nucleus of an atom during fission. So what happens during the fission reaction with the atom? They are asking like general question. You don't need to mention any equation, any numbers. So during fission reaction, we know a large nucleus splits into a more stable small nuclei, and it also releases neutrons and amount of energy, right? Nucleus splits into small, more stable nuclei, and it also releases and neutrons. Okay, in part 2 of this question is for 4 marks. And the question is, explain how fission can lead to a chain reaction in the reactor. So they are asking about the fission, that how fission reaction helps to start the chain reaction in nuclear reactor. Okay. And you remember we discussed this idea before nuclear reactor, that fission reaction works like a chain reaction because it emits more neutron. Those neutrons strike the other part of the uranium and this starts the reaction again. So we need to write for 4 marks, and this is very simple. Again, you can see this is a descriptive type answer. We just need to copy paste the concept we already studied about nuclear reactor and nuclear fission reaction, and you will get your complete answer. First of all, we need to start with the fission, that during fission reaction, we will get more neutrons, right? During the fission reaction, when large nuclei split into the smaller, so it also provides you additional neutrons. If you remember that chain reaction like this, we strike like one neutron strikes the nucleus, and in result we are getting more neutrons. So this is the first thing we need to mention, that during fission reaction, neutrons are also released. when heavy nucleus splits and the next thing is these neutrons are absorbed by the uranium in the reactor. So these neutrons are absorbed by uranium in the reactor. And the third step is the same copy paste step. Like it produces a more fission reaction and it will generate more number of neutrons. Because we need to explain the idea of chain reaction, that how it led to a chain reaction. So the concept is very simple. We strike a few neutrons on uranium, it splits into smaller, more stable nuclei, and it also gives you more number of neutrons. And those neutrons again strikes the uranium rod, and this process will continues to increase. Let's suppose we start with one neutron, and in output we will get three neutrons. So now those three neutrons strike the uranium and they produce their individual three more neutrons. Now those three individual neutrons produces more three neutrons of their single strike with the uranium rod. So in this way, just like in this diagram, we started with one neutron and we will get two more neutrons. And those two neutrons strikes the uranium again and they are producing two more neutrons individually. So you can see from one we got two, and from these two neutrons we are getting four. Now these four will produce more and we will get 8, 16, 32. In this way, we are getting more and more number of neutrons that helps you to continue the fission reaction in a chain form. Okay. So the third point is it produces more fission reaction because high number of neutrons strikes the uranium. It will increase the rate of fission reaction. And finally, there is nothing new. This process continues, and the number of neutrons we are getting increase again and again. So we are getting more neutrons. Your process increases again as compared to the previous stage, and this will give you the concept of chain reaction. So this reaction continues with the released neutrons. During reaction. And led to a chain reaction. Okay. So this is the explanation of this question for 4 marks, and it is very easy. We just need to copy paste the same idea again and again. And in the third part, state the purpose of the moderator in the reactor. So just like we discussed, that moderator helps to slow down the neutrons in the nuclear reactor. So you just simply need to write to slow down neutrons in the reactor. And in the last part, they are asking about control rods. So again, you need to copy paste the idea of control rods. Why we are using control rods? Because control rods absorbs the neutrons and it will decrease the rate of reaction, and it less neutrons strikes with the uranium rod and we will get less fission reaction. Okay.